Well, hi, everyone. This is Sebastian Traeger, Managing Director of Reliability.com, and welcome back to another episode of Reliability 4.0. As always, we're here to make the world a more reliable place. And today we are thrilled to have Allen Garcia as our guest. Allen is with Baker Hughes. He's also getting a PhD in mechanical engineering with a focus on AI. Allen, it is great to have you with us today.
Thank you for inviting me, Sebastian. I'm happy to be here.
It's our pleasure. Yeah, well, we are thrilled just to get an expert like yourself to be a part of this and to share some things. But before we get into that, I would love to just hear a little bit more about your kind of origin story. How did you get into mechanical engineering and then specifically kind of pursue that to a PhD and focus on AI?
Sure. No, happy to share that. Yeah, I'm originally from El Paso, Texas, and I started my education in engineering at the University of Texas at El Paso, UTEP. And at the time, my first job after my master's, I started in the mining industry in Arizona. And like most people that are reliability engineers, we stumble into it. Like I wasn't like actively searching reliability, but I just found it. And there's only a handful of schools that actually teach reliability in the country. But yeah, it's interesting how one just falls into this place. The interest of the PhD, I have always had it since I was back studying at UTEP. I just decided to take a break in once I finished my master's to go to industry, get some experience under my belt, and then subsequently go back to school to do the PhD.
It's great. Well, and you're doing the PhD up in University of Maryland, I understand. So
that's correct.
Lived in that part of the world for a little while, but really down in Austin is where you are now.
That's correct. Yeah, I lived on the East Coast for my first 4 years of the program, and then living here in Austin, Texas. And similar story of how I stumbled into AI. Like I started the PhD because I always wanted to have that level of rigor and professionalism in my understanding of engineering. And I just stumbled into AI, like without knowing that. I really wasn't applying for an AI program. I was just applying for a program that would fulfill my interest at the time, that were mechanical engineering. But it so happened to be that the funding was in AI topics, and then now it's grown.
Right. Well, and it's almost perfect timing for you, right? I mean, you couldn't have picked a better time to start a PhD with that focus, right? Had you?
Yeah.
I mean, it's just incredible.
Yeah. So I wish I could say it was that thoughtful that I actually meditated and made that conscious decision, but just serendipitously, that's how it happened.
Good. Well, we're gonna dive into AI here in a moment, but I always like to ask folks just a little bit about themselves outside of the workplace. Tell us a little bit about what you like to do when you're not kind of working or getting a PhD.
Sure. Yeah. A lot of what got me through my bachelor's and my master's back in El Paso was teaching yoga. So I have a great affinity and passion for yoga. I mean, I'm a registered yoga teacher with the Yoga Alliance, and that's what I do. I mean, I used to teach for years. Now I just have a home practice. I go to studios here in Austin. And then, I mean, with the pandemic that we had a few years ago, it was just a lot of virtual learning. And that's what I like to do. I like to swim, do some U.S. Master swim here and there, do some open tryouts and competitions in Texas. But then, just staying at home and reading and just thinking about something that's not engineering every now and again.
Right. That's great. Well, I'm guessing I'm not the only person who feels like I'm not flexible enough for yoga. What would you say to somebody like me? Would you say go for it anyway, or start with something simple?
I would say you're the ideal candidate for yoga. I think yoga is precisely for those that want to gain flexibility. So you don't need to fold yourself like a pretzel. Yoga is a very welcoming place, and just start slow, and then you'll build up a practice from there.
It's great. Well, I love that you've got such a deep interest in multiple things, right? Yoga, AI, et cetera. So let's get back to kind of AI and the work that you're doing. So talk to us about some of the problems you see AI being able to solve specifically in kind of the mechanical engineering world.
Sure. Yeah. I'll just focus the word AI into what my specialty is, which is natural language processing, or the more prevalent 3-letter word right now is LLM. So a lot of my work has to do with large language models. And a lot of the problems that large language models are solving for, let's refer to as industrial AI. So, and in the context of maintenance and reliability, all the problems that large language models are solving is to create knowledge bases for companies that you can ask, when was my last failure of this particular pump? Or can we make knowledge graphs to have a visual representation of when, like if this failure of a pump in this location happens, how does that relate to some other piece of equipment that's in the vicinity? And it's solving problems that can help us quickly retrieve information. They help us to extract insights and knowledge from the information that we have. Most companies are very data rich, and over the years, reliability engineers have been doing efforts to take that data to insights, fundamentally doing like mean time between failures at the start and then improving in maturity from there. But now with AI, that operation of an RE's day-to-day of parsing through data, it's been accelerated exponentially. So I think any reliability engineer, or any engineer for that matter, any professional for that matter, benefits greatly from the use of AI.
So that's great, because my next question was just going to be the impact on sort of reliability engineering specifically. So in a world where, I used to have to parse through a lot of data, and now some of that data I can summarize really quickly. What is that? What capabilities does that allow me to have? What does that allow me to do that I may have not been able to before?
Yeah, so the best use of that, let's say, extra time that one would have as an engineer would be to use that time for deeper thinking. The AI is good at doing quick thinking, not so much deeper thinking. So I don't think AI really is here to substitute a reliability engineer's job. It's more to augment what we currently do. So if I have to build an FMEA and that takes me a week, maybe that only takes me a few hours now, and I can spend more time validating the FMEA, facilitating the FMEA, and trying to get something more actionable and more practical from the analysis, and not spending that much time just doing the analysis. I mean, we spend, we go out for a week, we're in our desks just between ourselves and the data. We create this method, whatever that is, FMEA, RCA, RCM. And then we talk about that with the company or with the client or whoever that is that you try to make some inference of the data. So it frees us up to spend more time with the inference of the information. So yes, it can parse quickly, but then it might not do a good job at knowing, like, how does that information, this visual, this summary, relates to the context of my operation? And that's where the RE's job really shines. And then that person, the RE of the company, is going to know the context of that operation better than anyone. And then now you have just more time to do inference and to do something that is practical and of benefit for the company.
So I like that. So I liked how you made that distinction between quick versus deep, and basically saying it's going to do things quickly, but maybe not as deeply. How does one know? How does one know though if, whether I use AI to give me a itinerary for a trip that I'm taking, or what you're describing? How do I know if it's going deep enough versus just kind of hitting the surface level?
Yeah, no, that's a good question. Unless somebody is doing research in LLMs like I am, like, they wouldn't know the accuracy of these LLMs. There are leaderboards out there that offer you, like, how well does an LLM do on a specific task. I wish that more of them would offer some, like, quick number to tell you, like, the confidence interval or the accuracy of it. So in the absence of that quantitative measure, how can one know whether you're getting a hallucinated answer or whether you are getting the depthness of the answer that you need? That only comes from experience over time in a specific domain. So if you're new to reliability engineering and you're heavily relying on AI, then that might be a cautionary road to travel. You do want to inform what you're getting from the results from experience, if not from yourself, from those around you that have it.
So that's interesting. So in some ways, ironically, you would think AI would help the kind of less experienced, younger, if you will, folks. But you're almost saying, no, if somebody more experienced really embraces AI, it might even be more powerful for them because they've got that kind of quick ability, but they'll be able to see more accurately what's real and not real in it.
Sure. And just to be clear, it's not that it wouldn't benefit the younger engineer. Like, the engineer would benefit from perhaps getting the knowledge quicker, like learning quicker. But that engineer, because of lack of experience, may not really have the the ease to make the inference or to have a more profound inference that the senior engineer would. I think there's benefit in both experience spectrums. It's just different. You would want it for different purposes.
It's good. It's not going to replace intuition per se,
correct,
that wisdom, but it will. But obviously, the more intuition you have, it can really help because you know which direction to go.
Yeah, correct.
When you're thinking about, again, in your role, thinking about AI kind of at that PhD level, which areas of reliability engineering do you see as really ripe for, AI being a real asset and an assist in that regard?
Yeah, so like the one that most companies are chasing is to have an AI system, a chatbot that can serve as a knowledge base for the company. In other words, you see, well, when we had the advent of GPT just 3 years ago, everybody was chasing like having a ChatGPT-like feature in the company. Now they can't just simply plug in ChatGPT because of the data security and the ethics around it, which is a different conversation. So yeah, everybody's been trying to do something that's specific to them. So tuning it to their own organization. So in the context of large language models, most companies are using them to create knowledge bases and to be able to quickly retrieve information, either using a question and answering system or using another system that can help you just get the answers that you need quickly, but also accurately.
Okay. So, that feels like when Google launched, everyone's like, I need a Google widget on my website. This is obviously the next iteration of it, more intelligent, et cetera. But that's kind of that first step is like, take all my current data and just make it easy to access for everybody. What other applications are you seeing? And I think that's great. I mean, that does seem like table stakes, and I know there's going to be big companies going after that. What are other avenues maybe that you can see?
They're more specific to the tools in reliability engineering. So for example, can you take the raw data that you have, such as maintenance work orders and original equipment manufacturers, catalogs of spare parts, of how a machine operates, and the maintenance manuals? Can you take all these different inputs and quickly produce or go through the tool of doing a failure modes and effects analysis, a root cause analysis, or a method in reliability? So there's a lot of growth right now in automating the tools and techniques that we do in reliability, FMEA, RCA, to name a few, and to get that output seamlessly automatic. So there's also a big push right now in the industry to do that. There's also a big push for prognostics of machinery. So now equipment is sometimes perhaps overwhelmed with telemetry, with sensors and information that it's constantly getting and releasing to a single system. So how can we use those signals and that large data to make, again, inference from vibration trends, from temperature trends, from pressure trends? And then how can that then be connected to understanding failure rates? And how can that then be connected to understanding failure modes and the maintenance strategy as a whole?
Okay, good. Well, one thing you mentioned that, of course, is very interesting to us because our company sort of specializes in root cause analysis, is you mentioned people trying to automate that root cause analysis process. Generally speaking, how do you think people are doing at that?
The automation, you mean?
Yeah.
Yeah, so I think what I've seen in the literature is that, so there isn't like one or two companies doing this. This is dozens of companies doing this automation, and a mix of startups and a mix of legacy companies and Fortune 500 size companies. My impression of it so far is that it achieves various levels of accuracy. Like the quick implementation that I see is just to do an API call to ChatGPT and do some sort of chatbot interface to make that reality. I think the deeper, more mature aspect of doing an RCA with AI would be to say, like, you're tasked to do the RCA as an engineer. What is the first thing that you need to do? You need to collect the evidence. So in a lot of these cases, the evidence is already there in the system, like the failure history and such, and perhaps even images of the event. So how can we take all this evidence and quickly have like a first pass of the root cause analysis method?
Great. That's good. Yeah. So that's kind of going to be the start. So just kind of connecting it. I know you've seen our tool, EasyRCA.
Yes.
What feedback would you give us on how we're using AI in that tool?
Yeah, so I guess for the audience, if they haven't used the tools, in EasyRCA, like how I've seen AI being used in EasyRCA is a quick, well, just for everybody's context, EasyRCA uses the cost tree method, which is a visual representation of the RCA, but I think it also does like the 5 whys and the fishbone, like the more basic RCAs. But in a cost tree method, what it does pretty well is of automating the generation of the events or the causes, and then doing a prediction of if you have a cause that says bearing failure, can you predict what other causes are typically associated with bearing failures? So that's a great advantage. Another advantage is the quick summary of information. How can you use the chatbot-like feature to summarize, like you see a cost tree, but then how can you summarize that into a paragraph or two? Like if you were to talk about it with upper management. And then the other big feature that I noticed is, to my earlier point of ingesting raw data, of taking work orders, emails, and all the evidence, and how can you use that, how EasyRCA uses that information to automatically create the cost tree. So in those three avenues is where I see, let's call it like the proper use of AI to our earlier points of the motives around AI is to accelerate, so it accelerates the analysis. And then the second is the validity or the accuracy of that analysis. So while I'm not sure if there is like a quantitative like accuracy score, but certainly from a reliability engineer with experience, I can see and it's not complete hallucination. Like they make sense. You might need to refine maybe 20% of it, but it's not like you need to refine 80% of it. Like it gets pretty close.
And that's great. That's super helpful. And so if those are kind of three of the strengths, and I think that was a great summary, where do you think the biggest opportunities are? It's like, okay, well, here's where it is today based on where AI is headed and or companies beginning to build their own knowledge bases. What's the biggest opportunity for, say, an EasyRCA?
Yeah, so I think it would be assessing the rigor of the RCA itself. So how could we have, like, if a company has done 100 RCAs in the year, how can we help the company know, out of the 100, these are let's say the top 10 that were quote unquote well done. So there would have to be some rubric, some criteria to say, does it satisfy my maybe they have an RCA standard. Does it satisfy my RCA standard? Does it align with my business objectives? Does it follow a recognized RCA method, such as the ones described in IEC? So to have like an audit or an assessment of the RCA per se, that we could quickly see, like, these are the best practice of RCAs, because RCA specifically, because they're easy to implement and relatively inexpensive, it's easy to do many of them, but then are you doing them well? That would be my question. That would be my opportunity. Like how do you know you're doing them well, and how do you know you are right in doing the RCA? And most RCAs, they won't have like a quote unquote right answer or a final answer. Like they continue to grow, and they can be revisited. But my point is that there can be a level of robustness to say, can the AI help us say, okay, this is quote unquote enough in terms of, do you have the right amount of causes and descriptors that can drive you to an effective solution?
It's great. Yeah, basically they need like a GQ, a Garcia quotient on every RCA. It's like how
something
well.
like that.
But that would be incredible, right? To be able to analyze the work product of somebody and give it a 95% or whatever score you want to give it, completeness score or correctness score, because then, that's interesting. I mean, the question I then ask is, if you can get to that level, couldn't you over time just automate the entire RCA itself to where you don't because theoretically, if you're able to train a model on here's what a 95% is, right? Theoretically, it could achieve that score on its own.
Correct. Yeah, that would be what you described. There would be an application of transfer learning. So over time, yes, you could transfer learn. You could continue to train that model that is doing the RCAs and get them close to 99% of that Garcia quotient over time. I need to start writing and publishing that. But yes, effectively, yeah. Over time, you can get better. I mean, knowing that, what is state of the art right now in accuracy? Like if you look at the leaderboards in Hugging Face, for example, the accuracy average is between the 50 and 60% window, like overall.
Okay.
So there are 14 main NLP tasks, and amongst those 14, so there are models that do like maybe 80 in one task, but like an average across those 14 tasks, like a large language model right now is in the 50 to 60 range. So we still have a lot of room to grow and an opportunity to get more, to increase the accuracy of the models. And obviously we would need to like what that baseline is for EasyRCA and then grow from there.
So that's interesting. Kind of let's thinking about those 14 criteria for the models, or for the models are scored on. I guess two thoughts there. One, I would expect them to do worse on sort of engineering know-how because it's a more specified area, hence there's less data.
That's true.
So we expect there to be less than 40 to 50%?
Probably, yes. Like just an example, out of those 14, like some of them are like multiple choice question answering. Some are just like question answering. Some are like doing some other inference. But yes, you touched on something that is very, very much a hot topic in the research community, is doing domain specific applications. So there are all these studies and LLMs that are specific to medicine or biology or material science. But in what I've seen so far, what I've seen recently, I haven't found like a GPT level maintenance and reliability large language model.
Huh.
Perhaps companies have created their own, but at least there isn't one that's open source. And to be clear, that leaderboard is only on open source LLMs. Of course, companies might have their own proprietary LLMs, and perhaps they do operate. Perhaps they may perform higher than 50 to 60. But what's open source, or what somebody can see in the literature, there isn't like a GPT level reliability maintenance LLM out there.
Interesting. Okay. Well, there's a business opportunity. I'm sure there's multiple companies pursuing that. It'll be interesting to see if that emerges.
I'm sure, yeah. To give you an example, like the Project Management Institute, they have their LLM called PMI Infinity. So that it's a domain, right? They did a domain application of project management. So I envision, can there be something similar at whoever claims it first, right? Can there be something similar for maintenance and reliability at that level?
It's good. That's a really interesting note to think on. I was going to end with just kind of talking about the future, but I think that's a good place to kind of, just kind of leave it, is what is the future? It's probably, back to this idea that we're at a 40 to 50% accuracy rating. Obviously, for tools to become truly automated, that's not even close to good enough, right? To fully automate something. But you can see how a world where that keeps going up and the edge cases start to inform it are only gonna help it.
That's correct.
Which I think is a great, obviously I'm biased, but a great way to end, just saying why I think RCA is always going to be a useful tool, because effectively it's all about the edge cases, right? It's all about the cases where people weren't able to kind of predict what was going to happen and something happened unexpected. So it's kind of always going to be around and useful for folks, even as models become more and more important. Yeah,
the world is probabilistic, and there will always be unplanned events, unscheduled maintenance. We just can't get around that, the experience already knows that we're not pursuing 100% reliability, because we know we're never going to get there. We just need to asymptotically go towards whatever is good, 95, 99, or whatever we define as good.
It's great. Well, we appreciate you pushing us as a company. I know that we always want to make EasyRCA better and easier to use, but we also want to lean into AI tools, because I just see that as a massive part of the future, in terms of like the more we can make a tool that does not remove an RE from the process, but actually empowers them and allows their wisdom to shine even more. I just think that's the winning combination, is the combination of expertise with a tool that can go so much faster in bringing things together. That's where I think it gets really exciting.
Yeah, I agree with that. It's only the more honest and sustainable approach, the human in the loop.
Well, Alan, it's been great having you. And for all of our listeners, again, Reliability 4.0 is about helping engineers and really anyone take steps to more successfully use technology in their work. Alan is joining us. Again, he's a PhD in mechanical engineering with a focus on AI, and he has just been super helpful for us as a company. He's also at Baker Hughes. If you need his expertise, I'm sure he'd be happy to engage you and talk to you about that. And then again, if you're out there looking for any tools for root cause analysis, please check out reliability.com. We've got training under our ProAct brand, and then of course our software EasyRCA. And we want to join with you in working to make the world a more reliable place. So Alan, again, thank you so much for joining us. We just appreciate the time, and we'll look forward to having everyone join us on our next episode of Reliability 4.0. Thanks, Alan.
Thank you, Sebastian. Take care.
Okay.